In this tutorial, I'm going to walk you through the part design workbench in FreeCAD. At the end of the video, you'll be able to work with the bodies and the sketches and subtractive features such as pad, also called as the extrusion and revolution, and subtractive features such as pocket, groove, and other primitives, cube, cylinder, and spheres. And as a practical exercise, we're gonna model a gear and export it as a 3D printable STL file. So over here there is a basic knowledge that you have to have in order to properly work with the part design and understand how these shapes work. And you can see the part primitives. So part primitives are the basic geometric shapes, and they are used to build the core of a complex models. And these primitives can be found basically in the part workbench, such as the box, cylinder, sphere, cone, torus, wedge, and prism. You can basically combine these primitives to create combined models, like unified models using the Boolean operations such as the fuse, which is the fusion, and the cut, and the intersection in order to form the complexity of a model. Proper understanding of what additive features and subtractive features are important, because we perform additive features on the shapes that we create in the sketches in order to transform them into 3D models. These are the basic additive features. The first one you can see the padding, which is also called extruding. Extrusion works by stacking up multiple shapes based on a provided 2D sketch. So gradually creates a 3D solid object. Another one is the revolution. So revolution works by rotating a sketch around a specific axis. So you can decide the axis where the revolution has to be performed, and it also creates a solid. And the additive sweep is a sweep, and a sketch is dragged along a path and it creates the 3D solid. And the additive loft is used to create a solid by blending two or more sketches. And up next we have the subtractive features. So we use subtractive features to remove the materials out of a 3D solid. One of the commonly used subtractive features is the pocket operation. So we use pocket operation to cut into a solid using a sketch. And the groove is used to rotate a sketch around an axis to remove materials. And next we have the subtractive sweep. So it is basically used to remove materials along a path, which is the opposite operation for the additive sweep. And the subtractive loft is used to remove materials by blending multiple sketches. And for refinement, we often use fillet and chamfer. So basically we used fillet to round the edges and the chamfer to bevel the edges. And now I'm moving on to the demonstration where I'm gonna model a gear, and I'm gonna choose the XZ plane, and I'm gonna choose the polyline tool. First I'm going to model the side profile of the gear. To that, I'm going to use this Z-plane and create this shape. Be advised that you should always connect the lines into the XZ plane to help avoid the constraint problems of the sketch. You can see some of the constraints such as the horizontal and the vertical constraints. Those are automatically being drawn in the sketch as I draw the lines. That's because the FreeCAD automatically assigned them in order to streamline the design process. Well, now that the basic side profile is drawn, I'm going to use the constraint to transform the sketch into a fully constrained sketch. Well, before that, I think there's still one line is left behind. Okay, we're gonna draw that too. Alright. And now I'm going to, you can see these constraint error messages here. I'm going to take the dimensions constraint and I'm going to assign the dimensions into each line. Let's do 12 millimeters. You can see now the sketch is fully constrained and it turned into green. We close it. Oh, I think I have to fix this. You have to toggle the constraint geometry, because when you do not toggle it, it will not be appeared in the rendered 2D sketch. So we're gonna use the pad tool, pad operation, and I'm gonna set the length maybe around, no, before that. We're going to use the revolution tool. So it has successfully rotated the design and created this primitive shape of the gear. And right now I'm going to cut the teeth of the gear. So for that, I'm gonna go to the bottom side of the 3D solid and create a sketch. Right, and now I'm going to use the centered circle in order to support the circle that needs to be drawn in order to cut the teeth into the solid body of the gear. And you have to toggle the geometric construction here, so it will not be rendered but just as a reference. And now I'm going to use the radius constraint, and I'm going to assign the radius for the drawn circle here. And next up we're going to use a circle, and we're going to take the x-axis and the construction geometry as a reference for the teeth cutting. And I'm going to set the radius to 10 millimeters. Looks like I still have to toggle the construction geometry back to the normal mode. Well, I think it's better to scale down the radius of the circle. So I'm gonna reduce the radius and let it 5 millimeters, no, 4 millimeters in radius. As you can see, the center of the drawn circle and the construction geometry of the main circle aligns perfectly with each other. Let's fully constrain the circle. You're gonna take the center of the drawn circle into the origin and assign it 20 millimeters. And you can see it's fully constrained now. Now you can see the round circle is sitting at the bottom of the solid gear, and I'm going to use the pocket operation here, and I'm going to use the cut operation, and you can see the teeth has been partially cut. I'm going to set the type to through all and set OK, and over here on the toolbar, click the polar pattern feature. As you can see, the cut has been mirrored on the other side of their solid body. Well, let me show you again. Over here you can see the occurrences are currently set to 2, and I'm going to increase it, and it's gradually cutting the parts out of the body. You can basically set the occurrences as much as you want until you feel satisfied with the number of teeth that you need this gear to have. And the transformation is succeeded. You click OK, and you can see the primitive design of the gear is successfully implemented. We're gonna cut another set of teeth in this part. For that, I'm gonna create a sketch, and I'm gonna repeat the same process as we previously followed in order to cut the other set of teeth. Just like that, we create the reference circle, and we can assign the radius constraint, and we create another circle. We also have to assign the radius constraint into this circle as well. As you can see, there is still a remaining degrees of freedom here. So I'm gonna assign the length between the center of this circle back to the original coordinate system's center point, which also happens to be the center of the main gear's body. And as you can see, the circle is now fully constrained. And now you're gonna repeat the same process like we previously did. You basically use the pocket operation here. And this time I'm going to assign the length manually, not gonna set the type to cut through, and hit OK. Now it's nice and clean. And right now I'm gonna use again the polar pattern here, and now I'm gonna set the number of occurrences here to maybe like 10. And set OK. And now we're gonna have to make a hole on the top face of the gear. And I'm gonna create a sketch. And again, I'm going to draw a circle. Take the center point of the original coordinate system as the center line, and we had to toggle the construction geometry. Let's just turn it off from here. And you have to make sure the circle is fully constrained because there's still 1 degree of freedom. Use the radius constraint and set the radius into 3 millimeters. You can see over here now it's fully constrained. I'm gonna close it for now, and we're gonna use the pocket operation again. I'm going to set the type to through all, and I'm satisfied with the depth. Let's close it. I feel like it's better to increase the radius of the circle we used to cut out the teeth of the upper surface gear. Let's increase the radius into 3.5 millimeters. And we click OK, which is now it's better. Okay, now let's close this window now, and we're gonna have to, it looks messy, we're gonna go to edit the poly pattern we created. Let's reduce the number of occurrences here. Let's scale it down to 8. Now it preserves the shape of the gear. And now I'm satisfied with the design. Overall design is now pretty much look like an actual gear. So now we can work on the refinement aspect of the model. So for that I'm gonna use the fillet. I'm gonna use the edges of the top gear like this. Select all of these edges. And you can see simultaneously those selected edges are being shown in the preview box on the left. And now you click OK. Okay, there was an error message, and that is due to the fact that the applied radius happens to be conflicting with the original design itself. So let's reduce the radius. You can see the fillet is being applied barely, but let's just re-edit it. Now it's in micrometers. Okay, now it's considerably visible. So as the next refinement feature, we could use the chamfer. So over here in the toolbar, you click on the chamfer icon here, and we select these faces on the bottom body of the gear. You can reorient the model using this cube. Once all the faces are selected, you can apply the size here, millimeters. I'm going to do 1 millimeter. You can see I can increase it a little bit. Maybe I think 2 is. No, it compromised the nature of the gear teeth. So 1 millimeter. Okay, now click OK. Gear is how it's supposed to be, and it has all the characteristics, and we could export it. Oh, we have to select the object first and export it. Go to the files and go to the export option. So you give it a name, make sure the type is chosen as the STL mesh. You give it a name, you click on save. This is the STL file. You clicked it, you can see the STL view. So this is completely 3D printable model. So we have come to the end of the third video session in our FreeCAD course. So in this tutorial we learn how to work with the additive features and the subtractive features, and what are the basic primitives, and also how to model a gear using what we have learned in this video. So in the next video we will be exploring some of the advanced sketching techniques and the advanced constraints and dimensional constraints and etc. So stick around with us, just subscribe to our channel and turn on the notification so you won't miss any of the videos that we are planning to launch in the near future.